minutes or 2 years?
Dude, like, you're killing me right now. I'm just gonna say C, because that's what you do when you don't know.
Nicely done.
Good, thank you.
It's actually 8.3 minutes, meaning if the sun disappeared right now, we would live 8.3 minutes in blissful ignorance before everything went dark. Mommy? But that brings up an interesting question. We all know the sun has been shining brightly on our planet for a long time, like billions of years. So how much longer do we have, and why hasn't it burned out yet? To answer that, here's one of our favorite web series, Minute Physics.
Did you know that if the sun were fueled by combustion of, say, gasoline or wood, it would burn out in just a few millennia? So how is it still here after 4.5 billion years? Physics. The sun is like a big nuclear submarine in the sky. That's right, it's fueled by nuclear reactions that fuse hydrogen atoms together into helium and other heavier elements, releasing huge amounts of energy in the process. In this way, the sun is slowly converting its mass into energy in the form of sunlight, and it has more than enough fuel to last billions of years. But nuclear fusion's no walk in the park. On Earth, we need to heat hydrogen up 100 times hotter than the sun to get a fusion reaction. So how does the sun do it? Quantum tunneling. There's a small chance that hydrogen atoms, even if they aren't quite hot enough for fusion, will fuse together anyway. And the sun is so big and has so much hydrogen that these small chances happen all the time. And that's what keeps the sun energized. So when the sun shines tomorrow, give thanks to quantum mechanics.
So we've told you what the sun is made of, why it hasn't burned out yet, and how all life on Earth depends on it. But did you know we all experience the sun in totally different ways? Different animals, even different people see the world as illuminated by the sun with completely different eyes. Here's looking at you, Tara.
Have you ever heard that dogs can only see in black and white? Well, it turns out that's not really true. They can see color, but there are some pretty distinct differences between how we see the world and how they see the world.
To show you how dogs see the sun's light differently than us,
I want you to try and see things from a dog's perspective.
bad dog, get out of there.
Here's a test. Can you tell these two balls apart? What about now? Did you catch the difference between a dog's vision and a human's? Dogs can't distinguish between red and green. Most dogs have two kinds of color receptors in their eyes. Ones that can detect blue-violet colors and ones that can detect yellow-green colors. So to them, most of the world is a mixture of blue, yellow, and gray. Our color receptors can detect red, green, and blue, so we have a broader ability to differentiate between colors than cats or dogs.
However, there are plenty of other animals that can see parts of the color spectrum we humans can't see at all.
Here's a question for you. Ever wonder how bees find the nectar in flowers?
Many flowers have ultraviolet patterns on them, and since bees, unlike humans, can actually see UV light, to them, the flowers appear to have targets on them, pointing out where the pollen is. So how come bees can see UV light, but humans can't?
Well, the short answer is because we don't really need to see anything else. Bees need to see UV rays to find food, but that's not really the case for us.
But the truly remarkable thing is that even though we can't see the sun's UV light, with the right equipment,
it can actually help us see into the future.
Earlier, we asked you how hot the sun is. Do you have your answer? Well, I have a confession to make. It was kind of a trick question. The answer is all four. The sun's surface is called the corona. Not that kind.
The sun's corona is at least 1.8 million degrees Fahrenheit.
And it's the outermost layer of the sun. Let's start at the center.
The sun's layers are best understood by how energy is moved. At the core, fusion of hydrogen into helium happens at a temperature of 27 million degrees Fahrenheit. In the next layer, the radiative zone, energy moves by radiating outwards, starting at 12.6 million degrees Fahrenheit. Between this layer and the next is the interface zone where the sun's magnetic field is generated. After this zone, energy moves by convection at 3 million degrees Fahrenheit to the outer layers, where things cool down to around 10,000 degrees before we get back to the corona at 1.8 million degrees. How can we even begin to understand that kind of temperature?
Your toaster operates at 310 degrees Fahrenheit. That's the temperature at which the starches in your morning toast start to caramelize.
It would take 87,000 of these to even approach the core temperature of the sun.
Pretty wild, huh?
But what's even wilder is that massive amount of heat and energy is bombarding us every day. Isn't that right, Anthony?
Yes, it is, Travis. Now, some of it we can see as visible light, but there are wavelengths that are totally outside our perception. And if we could just tap into them, they could reveal secrets to us about the future. Beautiful day out, lots of sun. It's killing you. Are you wearing sunscreen?
Yes, I am.
Good. Good. You want to see the future?
What is this all about?
This camera takes a picture of your future.
What do you mean?
I like the way those break apart like that. You feel like you're pretty well covered in sunscreen because you're a pretty reflective dude.
Yep.
Do you want to see the future?
Yeah.
Come on into this tent. I'm going to take pictures of you. Hold it. Shouldn't be that easy. People should be more weirded out. So just step into the tent. You're going to sit at that chair and put your chin on the peg.
Put my chin on this peg?
Put your chin on that peg. So I'm just going to take your picture real quick here. Now, I'm going to take a different kind of picture. Pull this over you, kind of like a hood.
Hoods and pictures and tents.
Yeah, it's all totally normal. Grip it tight around your chin so we're not letting any light in. Boop, 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 boop.
Didn't mess up my hair or anything.
Give it one of these. So this is you on a regular camera.
All right.
This camera is a special camera that can see UV light. Anywhere the sun's kind of getting in is going to be bright. It's going to be glowing like a blacklight poster.
Okay.
All right, here we go.
Ooh.
Whoa, so that's crazy.
Oh, gee.
What are these people seeing that has them all hot and bothered? Any blue areas you see are not protected from the sun's powerful UV rays and could potentially become sun damaged in the future.
I have a mustache of freckles.
All those spots, is if I don't wear sunscreen, I'll get those things?
Yeah.
I'm not sure I should have come in here.
A UV image can reveal sun damage underneath the skin that isn't visible to the human eye, which is sun damage you didn't even know you had. And that's why this camera is showing you your future. All of those glowing areas are the places you're going to age.
Which is pretty much the whole face.
Oh, humanity.
Does sunscreen help at all?
Well, let's find out. Apply sunscreen to one side of your face.
Am I good?
Yeah, looking
All right.
good. We're gonna take another picture of you under the UV light, okay?
All right.
And yeah!
Oh, good.
Oh, man!
Oh, wow.
The UV is not getting in at all.
Wow.
And that's protecting your skin and stopping the damage from happening.
My mother always tells me to wear sunscreen, and I just don't listen.
You should always listen to your mother.
I know. Isn't that sad?
Yeah. Dermatologists actually use these cameras to help people identify areas that could present problems in the future, so they know where to be extra liberal with the sunscreen.
Oh, mercy. Oh, look at that upper lip.
You're fine. You're gonna be fine.
I'm only 16 years old. I have...
Now, if there's one thing we've learned about the sun, it's that it's totally amazing, but also not to be messed with. You can't live without it, and yet too much of it is a bad thing. I've had relationships like that. Thought I could do it. Thought I could go a whole day without thinking about her. Sheila.
Can you tell? Guys, this is my last line of VO ever.
Don't
Last
screw it
one
up.
we ever have.
Too early to get started with that.
Evolved to process just this. I screwed it up.
You screwed it up. I said don't screw it
It's a
up. and
long
you did.
sentence.